Be nice to the birds, and they'll be nice to you. But if you're mean, they'll poop on you. Yeah, oh yeah. Now, when you look up in the sky and you see one flying by, you better watch out, 'cause it might just poop in your eye.
Sweet mother of Goonie Goo.
Tell Keita he's on in 15 seconds.
Simple, yet satisfying.
What are you doing just staring?
Come on, guys. No more spit wax on the set.
Baby! Ready on the
All right, here we go.
Quiet on the set. Hear the music.
It's showtime.
Get ready to jam, man. Let's get ready to jam.
Hello again, and welcome to the Jam. Today, we're all gonna flock to our fine feathered friends. Consider the birds. It is estimated that there are nearly 9,000 different species of bird here with us on Earth. Blue jays, blackbirds, purple martins, and a few other shades as well. You know, when you sit down and really think about it, that's like billions and billions of birds. All over the world, birds are being counted, documented, and protected. One of the neat things about birds is that no matter where you live, be it the city, the suburbs, or the country, you can get involved with birds. And you don't even have to go outside. So today, we look at birds, the people that look at birds, and even the birds that look at us.
It happens on a boat called the Carefree Learner. Kids counting birds, protecting habitats, and getting involved.
It's different than most classes because like you get like to go out and interact with like nature and stuff and get hands-on experiences and stuff, and it's just nice being on the water. And
How did you find?
for each of the 3 islands, we write down the number of birds, the number of nests there are, the number on the nests, the offspring, and just the total number of birds we see all together.
What we'd like to do is to protect these islands by having a no-wake zone in here, and the students are using their data to petition the state for that purpose. They have already asked the state to put no trespassing zones here, and the signs you see on the islands were actually erected by the students.
Mangroves are the saltwater trees.
They're what traps the sediment for the islands to build and maintain their same size and shape. And because of the wake, it's eroding the islands away and making them smaller, and the mangroves are eventually dying.
It moves the sand ultimately, and the mangroves are here to hold the sand in, but they can only do so much, so.
And as they die back, then there's less and less islands for these birds to nest on. You know, the students are very aware and cognizant of the problem, so if we can help the public understand that this is really one of the last strongholds, and these species have nowhere else to go. And if we can get them to put a no-wake zone here, we might be able to slow down the erosion and protect these islands.
Well, when we were freshmen when we started, I was like, basically, yeah, okay, we're going out on a boat, we get to get out of school, this is cool, you know? But yeah, like the more we study it, the more I realized how this really does affect our like daily lives living in Sarasota, because you know lots of people own boats in Sarasota, and they're just by driving by in their boat, they're ruining the habitat for the birds.
So if we do our part and we just keep sending in data and showing them that what's happening, what the boats are doing with the wake, and what's happening to the islands, and eventually maybe we can help slow down the process of what's actually probably naturally going to happen if nothing's done.
Yeah, I mean, it's something that we need to cherish, and it's something that's important to us. So yeah, definitely, our mindset has changed.
Cable Channel 39 presents visiting ornithologist Ingmar and Vespa. They will be discussing their observations on birds of the world.
Und der Glockenspiel. Und Hi! Und der Mi und der Vespa.
Und der Schmetterling, der ist ein guter Mann.
Und der Fleisch und der Birne. Und der Lessen und der Unterklaufen fließen. Vespa.
Erstens, der ist der... Mach doch
Und du warst unter Plünit. Und du warst unter Molten. Und du warst unter Hatchen unter...
Dann komm der her.
Oh, shit, like unter Schellen unter Egg.
Und ein kleines Baby.
Autschen. Und der Blistering und der Itten und der Sieden.
Aber das ist gut.
Und der Lanchonen with a Barbie.
Das ist schön. Und auch so. Und auch die.
Oh, schön und der Flying und der Arten und der Pläsen. Und der Bei und der Mien und der Vespa und der Frau. Und long.
Ingmar and Vespa, thank you very much.
One of the greatest things about bird watching is you can do it anywhere. I mean, I get to travel all over the place to look at birds, but my favorite place is right in my backyard because even in a city, you can have birds anywhere. Even in New York City, you can see hundreds of different kinds of birds. I mean, they're everywhere, so it's something you can do no matter where you are.
Now, the center itself, what we try to specialize in is in satellite telemetry, aka the satellite tracking of migratory birds. And basically, we're looking at the tundra peregrine falcon to understand bird migration. What's migration? Moving from one place to another. Moving from one area to another area by means of instinct or by means of planning it out. But why do birds migrate? Why would a bird go through all that trouble to cover thousands and thousands of miles in order to migrate? Why would we go through all that trouble? One of the three big reasons I see as far as bird migration is food source. That's one of the big ones. There's a whole food source up here for them. There's a total niche up here for them they can take advantage of. They can come all the way up here, start feeding like crazy, be more successful breeding, and that's the key. Another reason is not only food sources, competition. What about a lot of our native tropical birds that are here, our perching birds, that are very different colors. Say we have magnolia warblers or yellow warblers, or indigo buntings. Really colorful birds, which you only see in the spring, originated from South America. Another aspect is genetics as well. It's ingrained in a lot of birds to keep going. That's a trait. In order for them to survive, that trait has been passed on by many and many, many generations in order for them to keep migrating. Where do they live? You don't know where a tundra peregrine falcon lives?
Tundra.
Tundra, there you go. That's where they breed. The breeding areas is in the tundra. This bird will be following its track from the tundra all the way down to South America because it's instincts, it's genetics, it's in the genes. It knows it has to go there. What we use is satellite transmitters. And what these do is they send a signal to a low Earth orbiting satellite. And it's a Doppler signal. So it sends up, the satellite collects the data as far as where this transmitter is. Wherever this transmitter is located, it'll send a signal to the satellite to tell it where it is exactly. Satellite telemetry really helps us. Every single bird we put a transmitter on, we know where it's wintering. We know where it's going.
Right down to a couple hundred feet.
Yes, exactly.
We can go right to where they're wintering and spot them and say this is where they are, that's what they're feeding on, and this is the habitat. We can say if there are chemical contaminations in the area.
The only way we're able to get this answer is by following the peregrine falcon, because our little dicky birds can't handle any of these. So we have to use a sentinel, somebody to represent migration, and that guy did a really great job.
Bin ich ein Vögelin wir? Und nach zwei Vögeln hat's das Flügel zu dir.
Und spitting und der Ludwig und der Fleigen.
Part of it is that birds are such a part of our everyday lives. I mean, it's probably the most common type of wildlife that we see. They're around everywhere, and I think sometimes we take them for granted. And what we don't think about is that birds are really indicators of the health of our ecosystem. And if there are lots of birds around, like we're seeing here, then we're probably in a place that's pretty healthy. But if we came out here and there were no birds, then we'd have some real problems. There'd have to be something else going on here that we'd want to learn more about that was causing the birds to be absent.
Nice one!
Avian hypercommunication test number 31. After rerouting the flux capacitor through the picoforms compensator, I have created what appears to be a multi-phase pulse wave that is spread throughout the area. Have commenced communications transmission, but have had no response from any birds. It's got to work. Birds, dinosaurs, aliens. The connection is there. I know they hold the key to life on other planets. What secrets can I unlock? The origin of birds, the mechanics of natural flight, how to pick up chicks by breaking a funky groove.
Hold it, mister. Birds, their nests, eggs, and even the feathers are protected under federal.
Or are they just the morons of the sky?
The tiniest bird in the world is the bee hummingbird. It also lays the smallest egg, about ½ an inch long. The biggest bird in the world is the ostrich. It lays up to a 4-pound egg. That is a big egg.
It's thought that the very first bird was the Archaeopteryx. It lived about 140 million years ago and was the size of a crow. Similar to a reptile, but not really one.
Well, sometimes you have to be kind of a detective to find birds out here. We're out in this great spot, and there's all this great habitat, and I can hear some birds, but I can't see any. So we're going to play a bit of a trick on them. So I'm going to do my owl call, and we'll see if any other birds come out here. Here we go. And sometimes when they hear the owl, they start to scold it, so I'm going to imitate the scolding sound. It's a great way to get the birds to come out of the brush so you can get a look at them.
It might be only a friendly blue bird called a scrub jay, but these students are learning a lot from it and doing their best to make sure it doesn't become extinct.
Probably go on field trips 6 to 8 times a year to different habitats, a chance for them to get out and view Florida's different habitats as we would with any other state, wherever we were. It's an opportunity. They've been introduced to one, and hopefully they'll continue to carry this on and learn more about different species.
We want this bird to be the state bird for Florida, and one of the debates was, you don't see them everywhere. So that's why we make environments like this, hopefully to increase the population of the bird. Therefore, nobody can complain about not having enough anymore.
Certainly puts a name and a face on the things that they're trying to conserve and learn about. It's one thing to look at pictures in a book or even on TV, but it's another thing to go out and actually experience the things firsthand, which is what the students are doing out here.
I didn't know anything about the bird before I started, and then once I got started, I learned so much, but not only about the Florida scrub jay, about my environment, about its environment, about a lot about endangered species, plus we've learned a lot about government. I'm an outdoors person now. I love camping, I love going on hikes, I love doing stuff like this, and this is what started it.
Mr. Cole was the one who really introduced me to the scrub jay and how it was a endangered species and it was an important bird, to our habitat. And I fell in love with these birds, and I try to come out here when I get time to.
Well, I just like going out into a natural state and being able to, communicate with the animals. I mean, see them, view them, see how they live. Ever since I started coming out here, it's been something that I've really enjoyed, and I come out a lot.
Birds actually walk on their toes and keep their heels in the air. They also have no teeth.
Hang it up.
Primarily, the Sutton Avian Research Center worked throughout the southeastern United States, and we released eagles into Alabama, Mississippi, Georgia, North Carolina, and Oklahoma. So what we did was we went down to Florida, which has over 600 nesting pairs, and we would pick up eggs out of the nest, which is much easier said than done, I can assure you. We would have to climb these 100-foot trees, and we would collect, around 60 eggs per year. And we would then drive them back in a motorhome. From the time that we picked them up, we had to have them in an incubator because they have to be kept within 0.5 degrees Fahrenheit in order to hatch them. We would then raise them by using puppets which we fed the young eagles with, and so they would not be tame. We wanted them, of course, to be wild, and then we wanted them to be imprinted on their own image. Then we built 30-foot towers that were barred on top, and we would put the young birds in there at about 8 to 10 weeks of age, and they would stay in there 2 to 3 weeks, and during that time they become fixed on that location. We would release the eagles after they had spent a couple of 3 weeks in the tower. They'd have radio transmitters on them, and they would home back daily for 2 or as much as 3 months to this tower and get food that we placed out for them. And in doing that, they learn to hunt on their own. They don't need to be taught by their parents. It's genetically programmed. And they would eventually disperse. The first year after we released birds, say here in Oklahoma, we had 1 bird back in the spring, but it wasn't long before we had birds nesting again. And now, here in Oklahoma, where we had no eagles nesting at all, we've now got about 33 pairs back nesting as a result of our release program, and there's similar numbers in the other states where we work, so we're very proud of that.
What's happening, my people? Right on. It's me, your fellow Funkadelic, just here trying to get you to understand a little something about the birds. Yes, I'm here to defend the birds. Why? Because they ain't do nothing to nobody. They minding their own business, flapping around, just trying to find a little nest to call home. That's why I got my hair like this. Anyway, I'm just here to let you know it's all about defending the birds.
We're trying to learn scientific things like population of certain birds and where they migrate when, and the numbers of males and females.
You know, we have birds that are migratory in this country, some that migrate south for the winter. We even have some that breed in the south and migrate north for the summer. So we have migration going different directions. We even have migration going from the east coast to the west coast and from the west coast to the east coast. It's the insect eaters that we find are include most of the migrants, because in the wintertime, there's no insect food available for them, unless there happen to be a woodpecker, and then they can dig their insects out of a tree.
The bird will come and it won't see the net. As you see, it's not real visible, and it'll come right into here and it'll bounce into a bag. We have a bird here. This bird doesn't have a very strong bill, so it's not gonna hurt, really, if it bites. Other bigger birds would hurt a little bit more. If you don't know what you're doing, the best thing to do is just sort of stay away and you can watch it, but don't try and catch it.
Wild birds are protected by both the federal and the state government. Any work with wild birds, any handling of them, any manipulation of them requires special authorization.
You can kill the birds. There's a high risk because they can become very stressed out if you don't know how to get them out of the net properly. I think I finally got it. Yes, we got it. We got it out. Yeah, it's a nice cat bird.
Bird bands come in a string of 100 for songbirds, and they are in numerical sequence, and they have to be used in numerical sequence in order to keep the record straight. Okay, and now you've got it. There you go. You're going to slip that all the way in and squeeze as hard as you can. Got it.
Sometimes birds can be tagged. Again, what they're doing, they fly back into the net, and you'll catch them again, and you can see when they were last dated, and you'll still record this band number. He's ready to be released.
To release it, we don't toss it up in the air. We just open our hand and let the bird go. If the bird is held on its back, it doesn't realize that it's not being held, even though you open up your hand, because a bird normally has no pressure on its back. So if it's got pressure on its back, it thinks it's still being held. And you can hold it like that, and it just thinks that it can't get away. But if we turn that bird over, off it goes.
what kids need to understand is that birds are just so important as part of our environment. I mean, they do so many different things. For example, they're one of the best forms of natural pesticides that you'll ever find. Birds eat millions and millions of pounds of insects every year, everything from the mosquitoes that bite you to the bugs that are eating your mother's roses. And so they're great to have around for that reason. They help regulate the environment they're in. They control the prey species that are out there and they're food for other species. They're just part of this web of life that's so important for people because we're part of that web too.
Attention all units, we've got a runner. Roger. He's going 1026 to go 3.
You are so dead!
Roger there, 200. He's running like a scared little bus.
I'm hoping on you!
All right, I got a lock on him. You're clear to fire. Final one. Well, let me tell you something. You respect the birds, and they'll respect you.
He's in the flute. Flyby, und die Kochen und die Pillen.
Schön. Schmetterling, zweitens.
Wo sind die Eggen? Eggen ohne Belogen.
Vögel, das ist ein schönes Gefühl.
Nein.
Doch, das ist der Vögel. Vögel?
Oh, ze moet blijven, moet klein goed.
Das war's. Am I on? Is this thing on? Hi, I am now reporting live from a scene where it is absolute chaos here. In fact, we are looking at what looks to me to be absolutely no science here. And oh my gosh! It looks like right is now left, left is now right, up is now down, down is now up. I can't really put into words exactly what I'm seeing here, but it's utterly amazing, folks. And now we'll take it back to you in the studio.
Tell Keita he's on in 15 seconds.
Simple, yet satisfying. Come on, guys. No more spitwise on the set.
Baby! Ready on the... All right,
here we go. It's showtime.
Get ready to jam, man. Let's get ready to jam.
Hello and welcome to Head Jam. Today on the Jam, it's the big world of science. We're going to take a look at the many ways that science plays a part in your life. Almost everything you do, see, or touch has some aspect of science somewhere in its past. Take this 2-liter bottle of root beer. Over 100 years ago, food chemists began experimenting with the flavor, but the formula has been developing and changing ever since. And the bottle itself? Well, science has had its hand in it in several different ways. Back in the day, it was the glass bottle, to the tin can, even to aluminum, all products of science. And nowadays, we have plastic bottles that have been designed and engineered airtight to hold in all of those wonderful bubbles that make you burp. This is just one way that science works to make our lives so much better. From the foods we eat, to our houses, even to the clothes we wear. Applications of science are everywhere. That's right, it's all about applied science. That's when science moves into the real world to solve real problems.
It's a conspiracy. There are people, they're out there, and they can find me. They know how. They can tell if I've been around. You see, they've got the technology. It's something called forensic science. Whoa! They can take even the smallest little tiny teensy speck of dust and they can match it to stuff that you've left lying around the house. They can test hair, fibers, paint, and my personal favorite, blood. Blood. You see, they put them together and they see what matches and what's similar and what fits. They can tell if you are really you by your DNA. Anyway, that's how I know they're out there. And that's how they know I've been around. Yes. Hey! Oh.
Crime scene evidence comes in all shapes and sizes. Forensic scientists at the Federal Bureau of Investigation perform more than 1 million investigations a year. The goal is to recreate a picture of what really happened. Think of it as a puzzle with some of the pieces missing. Forensic scientists use their knowledge of science to complete the puzzle.
Every case that we have, the question is, could this have happened and can we show that it could have happened? So really we're kind of a fact-finding mission every time we do a case.
The process begins in the scraping room, a room that's thoroughly cleaned before and after each use. It's critical to keep the evidence from being contaminated.
We want to make sure that there's nothing in there that we're going to introduce to the evidence. We want to make sure when we take that evidence out, what's on the evidence is what we're going to find and nothing else. What we're looking for are hairs and fibers. We have actually other people who may look in the same debris that we have for soil or glass or paint chips or any other residue. So really, anything that's on that clothing is probably going to get looked at by somebody. Okay, the way we do a hair comparison is using a comparison microscope. And this is just 2 microscopes joined by an optical bridge. So it lets me look in one set of eyepieces and see 2 hairs side by side. Because we have it in a mounting medium which allows us to see the internal characteristics, it's those characteristics I'm using to do the comparison.
Forensic scientists at the FBI use a wide variety of scientific tests as they examine evidence.
Paint chips come in on victims' clothing in pedestrian hit and runs, or the paint chips may come in from a medical examiner at autopsy. Sometimes we're able to come up with makes, models, and years of one particular color. Other times it could be this particular color from this auto manufacturer or this color from this auto manufacturer.
One scientific process that has become essential in criminal investigations is DNA typing. Investigators can now prove if a suspect is connected to a crime scene.
In order for us to carry out comparisons between crime scene evidence and individuals, we only need to look at a very small part of that. Postage stamps, cigarette butts, envelope flaps that are licked, just about anything that contains biological material is fair game for forensic biological DNA analysis.
When we find one that we consider a single stain coming from a single event, then we'll circle that, test it to see if it's a biological fluid, and in this case we're looking for blood.
DNA typing is an extraordinarily valuable tool, and you hope that forensic science puts enough pieces of that puzzle in that even though some may be missing, the jury can still tell what that picture represents.
Well, miss, you need a job, and I'm the fella to find it for you. So tell me, miss, is it Skainke?
Science?
Science. Oh, so just a whole lot of those suckers are silent there. Miss Science, why don't you tell me about yourself so that I can find you that job?
Sure. Well, I have a lot of experience in problem solving. Many successes, a couple little failures.
Failures?
Learning experiences.
Oh, okay.
I have lots of new ideas, sir.
Okay, yeah, shush. Before you just prattle on, how about we take a look at the resume? I think that can give us something concrete and valid and large. This is a little big for what we call a resume. I think we need to work on what people might call a cover letter.
This is the cover letter. Can we bring in the resume?
That's not a resume. That's a rainforest. How about we do what we call editing? We hone down the pages, maybe take one.
You want me to take out penicillin, atomic energy, what?
how about, oh, there's the migraine. How about we just start with your most recent accomplishments, okay?
Well, I'm very proud of what's been going on with the Human Genome Project, exploration of Mars, artificial intelligence. I like to see myself as a problem solver, really. It's a cycle. Question, answer, new question, new answer, new question.
I was looking for something a little bit more concrete, something that we could actually use to, well, get you a job. But since you have absolutely no qualifications whatsoever, how about we find you something at the mall? It's called the science of the hot dog with the corn surrounding it. Capiche?
Weather is critical information, whether you're deciding whether to wear a short sleeve shirt or a long sleeve shirt to school, or whether you're deciding whether you're going to need to take shelter from a tornado or a hurricane or a winter storm. So weather affects everybody's lives.
Here at the National Severe Storms Lab, we study all kinds of severe and hazardous weather, including snow and bigger thunderstorm complexes that might rumble across the plains all night long, you name it.
Scientists, like Daphne, are working to better understand the Earth's complex weather and storms, especially tornadoes.
We know a lot about the kinds of storms that tornadoes come from, and we're pretty good at forecasting that kind of storm. But those storms don't always make tornadoes. In fact, very few are the really bad ones that you hear about. I've always loved science, and I've been involved in some of our field work where we've gone out with instrumentation and driven right up around the vicinity of a tornado, for example, and you're looking at the storm because it's right there, and it's sort of like hunting in a way. You don't really know what's going to happen when you leave home, then you take your chance on whether or not it does. It may not seem like much, but the distance between the bottom and the top of the storm can be as many as 11 miles or more. Okay, so we're talking the top of the storm might be 50 or 60,000 feet. If you look at that on the Earth, that doesn't seem very far. With the atmosphere, that is a big, big difference. That's why storm spotters are still important.
We like to think of the National Weather Service as where weather begins. The weather information, whether it's surface observations or radar or forecast, begins in your local National Weather Service forecast office. We hope that research, new radar technology, new training with forecasters, increased spotter networks will help us detect those storms and issue better warnings.
In terms of severe weather, we still don't fully understand how and why hail forms. We still don't understand all the processes involved in rain and rainfall and how much rain you'll get from one storm or another storm. That sounds really fundamental, but it's true that we still don't have some very fundamental pieces of what's going on with the weather.
Meteorology is, first of all, an inexact science. We're not able to forecast with 100% accuracy what the weather is going to be. And so it really doesn't matter what TV station you're watching, whether it's a cable channel or your favorite TV weather person, they're getting their information from the National Weather Service. Now, what they do with that information when they get it is up to them.
Weather is not the only way science protects society from Mother Nature. Scientists around the Earth are working to develop better ways to warn us about natural events. South American scientists are studying volcano activity in Chile.
Man no longer studies the volcanoes out of pure scientific interest, but because he wants to know what it's going to do and how it's going to affect him. In order to monitor volcanoes' behavior, the volcano will exhibit certain symptoms of what it's going to do in the immediate future. For example, a volcano may increase its seismic activity, or it may change its composition of the gas it emits, or the volcano itself may swell physically. One of the techniques which has proven most reliable in recent years has been the measurement of seismic activity. For this reason, we place seismic monitoring stations with seismometers in the volcanoes, and these stations send a signal via radio. The signal is sent to a station where it can be logged on a computer. When there's a sudden change in number or type of seismic event, this alerts us to a possible seismic problem.
Scientists have created a traffic light system to warn about potential volcanic activity.
So the observatory is not only a place where we carry out scientific study, but we also contribute to the safety of people who live nearby.
I think worms are just cool. I mean, they just really are cool, because worms are creatures that we see out there, but we don't really know a lot about them.
There's more to earthworms than going fishing. These worms are solving a problem by turning food waste into rich compost that will help grow more food.
We actually start the process in the kitchens. Before we start our food waste program, all of these types of materials were going either in the trash or down the drain. And these materials that you see are basically just part of the kitchen prep waste when they're preparing the meals for the day. Somebody had scrambled eggs for breakfast. Got some cucumbers here too. The bananas, and they are the favorite of the worms. Worms actually kind of slurp the food up, so it's real important that we grind the food. We have a grinder. It's not always clean work because grinding up food can get a little messy sometimes. Well, this is a 6 by 8 foot worm bin. It's a industrial-sized container that actually houses about 50,000 worms. We use red worms in this worm system. Red worms are the typical worm you might find if you turned over your leaf pile or to kick over a manure pile in a farmer's field. Sometimes people think I have night crawlers, the big old juicy worms, but night crawlers actually live too deep into the earth to be the right kind of worm for this type of system. Put some food waste into it along with some of the newspaper that you see, because the food waste in combination with the paper creates the perfect environment for them to be able to live and breed. So as they would eat the food and process the food, they would just work their way to the surface to continue with their feeding frenzy. And the bottom part of it then is actually finished product. The worms themselves aren't the only ones breaking down this food. Of course, there's other microbes and living organisms within the worm bin that help break the food down before the worms actually can get to it. So it is really quite interesting. If you were to grab a handful of compost and throw it under a microscope, you'd see a lot of living creatures there. They're just a natural part of dirt and, you know, organisms that work together.
Hello, I'm back with more that you need to know because, believe it or not, children, there are people who want to know everything about you and everything about me, little old me. But I don't like the man looking over my shoulder. I am the man. So I shred everything. That's right. Every piece of information I've ever had, shred it all right here so that nobody can see it. Of course, sometimes the shredder's just not enough. That's why I go to the next level. Worm-o-matic! That's right. This ain't no namby-pamby shredder, people. It's science! Although even though the scientists who use real worms have got something going, I have the secret weapon. Sour gummy worms. Oh, the sugar really breaks everything up. See, I told you there wasn't a chicken in there. And at the same time, when I'm done, I've got a nice little garnish from my veggie garden. Now, come on, where's the bird in here?
All right, drivers on the line. Human players on the mats. And 3, 2, 1, go!
The battle is on. Robots and high school students in a national competition all about science and technology.
We've just built it over last year, and it's been a continual process basically.
We were picking up boxes this size. This is actually a type of box, and we're picking them up and stacking them in a zone.
Basically, you tried to knock boxes into your zone, but it turned out the main strategy was just knock everything over. There wasn't really much stacking involved.
It's pushing the entire stack over onto the blue side.
I think it's a combination of engineering, a little bit of science, and technology. It's basically engineering because we had to fiddle with a lot of things.
We had to learn about basic pneumatics to make the arms move in and out and up and down, right?
And also we got to use a lot of technology with wiring the brain, doing the program that actually enabled the robot to run.
Although that was technology, it was science in the sense that we had to figure out the turning radius, how much power we could put through.
I'm always afraid they're gonna break it. Well, 50 years ago, people thought of robots in sci-fi movies, kill robots, kill! In the 70s, robots was a dance. It wasn't anything you had. Now it's something that's on TV.
It's really possible that in the future we could actually have robots in houses. They might not be extremely sophisticated.
Like the RoboVac that are just wheeled that do simple tasks.
Definitely not any robotic nannies or anything among that nature because they'd blow up probably.
Nobody 30 years ago would have said that we would have had computers in our houses. But now we do. Everybody has a computer in their house.
Maybe in 10, 20 years, we'll have robots in our backpacks and at home.
I think ultimately we'll end up having them.
Nanotechnology!
Nano. It's a size thing in a whole new world. Think of a guy over 6 feet tall. This fly is 1,000 times smaller. Inside the fly is the nucleus of a cell that's 1,000 times smaller again. Go 1,000 times smaller again and now you're in Nanoland, a place where scientists are developing tools that might change the way we live.
So the idea is, can you take small entities like molecules and use them for individual functions? That function may be as an electronic switch, it may be as a transistor, it may be as a memory element, it may be a machine, it may be a truck, but now you have many of them. You say, well, how much function could a truck have at this small dimension? Well, the truck couldn't carry that much. But if you have a lot of trucks working for you, if you have 10 to the 23rd trucks working for you, you can move a lot of material. So just the sheer number allows you to have tremendous power at your fingertips.
You can build a nanometer scale piece of material to make a better computer, to make a better sort of airplane wing, or you can also build one to make a better type of medical spectroscopy. So the idea is that nano is a tool that we can use and apply it in many, many different areas.
I want to stand here someday, not too many years from this, here, and hold a new crystal in my hand, something I can feel and touch. This single crystal will be the best conductor of heat in one direction of anything that's possible in the universe. In addition, it'll be so strong that if you bend it back and forth, it may not be possible to break it. In tension, it will be 100 times stronger than steel, the strongest thing in the universe. Somebody is going to make this. I'm convinced. I do not yet know how, but that's part of the fun of the game. Try to figure it out, find a path.
In 50 years, I think that this whole nano business will be everywhere. It's going to turn into something that's as ubiquitous as plastics. You know, plastics and polymers are everywhere in our life. We don't even think twice about it. It's in our packaging for our cereal, it's in our CD cases. And I think a lot of nanoscopic materials are going to become that way. They're going to give us much better materials and much better technologies, but it's going to be a part of the fabric of our lives, and it's going to be everywhere.
There you have it. Everything we do, see, touch, and feel, it's all there. Science. It's a way of thinking outside the box, asking how and why, and applying our knowledge to making the world a better place. That's what's up, y'all.
When they say of something, this is going to be delectable. Another cake ruined, but I followed the recipe, sort of. Oh, what's a man to do? Help!
Don't worry, fair citizens. We're here to help.
That's right. We'll save you from this kitchen disaster. We're the Science Twins.
Brain on!
Twins, right.
It's a science thing. You know, powers of the universe, hero type stuff.
Never mind that. You're just 3 simple science facts away from cake success.
Egg whites have 2 proteins, which when brought together form a glue, which becomes a stable foam structure.
That's your cake.
That explains a lot.
The heat of the oven warms the air, which expands the batter to make a fluffy cake.
Remember, hot air takes up more space than cold air.
The right time and the right temperature help the proteins coagulate in the oven.
That means they become solid. Now, you do want cake, not pudding, right?
Wow, thanks, Science Twins. I understand now. But what about my cake?
Thanks to the power of science and the magic of television, we just happen to have this lovely cake.
Farewell, citizen.
Circle snap peeps.
Don't miss the next exciting knowledge adventure with the Science Twins!
Okay, so Miss Science.
Science.
You know, you've done, it says you've done research at universities, corporations, with the government, basically for everyone, everywhere. And so, what problems that I have you solved?
Let's start with the weather. With the research that I've done, we've been able to develop ways to forecast and predict storms much, much earlier in advance, which helps save lives like your own, as well as farmers and...
Weather girl. Huh? Huh?